Ah, welcome, fine physics folk. Happy Monday. It's good to be here on the start of another week on our physics journey that has been very odd, but continuing nonetheless. Last week, I introduced the concept of potential and kinetic energy. Today, we're going to kind of get a little bit more into what this means. I just want you to know that this concept of energy is what we're going to probably spend the majority of the rest of the year doing because it's such a fundamental concept of physics. If you go into any science beyond this in college or whatever it is that you do, energy is really the one topic that kind of transcends all the sciences. You studied energy in biology with cells and ATP and ADP, all that stuff, photosynthesis. You studied energy in chemistry with spontaneous chemical reactions. Is there enough energy to get this to go? Heat and all that good stuff. So we're going to go ahead and talk about energy in physics with energy transfer because energy is a topic that really is in all of the sciences. So, that being said, I may have said some things that you didn't know, and that's okay. Today, what we're going to do is practice with the energy equations that we already have. Last week, we introduced the two types of energy that we're going to be focused on in this class, potential energy and kinetic energy. This photo kind of helps illustrate some of the differences between them. Potential energy, as the car on top of the hill, the car has potential to fall down, to go down, so therefore that has potential energy. Kinetic energy, the woman in the swing is moving, and therefore she has kinetic energy. We're going to review this now. Okay, potential energy. This one's a little tough for people to kind of grasp, but I want to make sure that we really do understand this. Potential energy is the energy that an object has because it has potential to fall. So look at the rock in the picture. Is that rock moving? No. But does it have the potential to move? Yes. If you pushed it to the right hard enough, it would then fall down the hill. You would be releasing its potential energy. So if any time an object has potential to fall, it has potential energy. If an object has potential to fall. So you don't need to be moving to have potential energy. I mean, if you're sitting at a desk and you have your pen on the desk in front of you, your pen is not moving, but if you knocked off your desk, it would then fall. It had potential to fall. That was its potential energy. Kinetic energy. This one is the simpler one to understand. Kinetic energy is simply the energy of motion. Any object that is moving has kinetic energy. Only objects that are at rest or at a stop have no kinetic energy. So, we've been talking a lot about motion and moving. Anytime an object is moving, doesn't matter what the object is, if you're moving, I don't care how slow, but if you're moving, you have kinetic energy. The only time you don't have kinetic energy is when you are entirely, completely still. All right. And this is just a quick review of the equations from last week. And if you don't remember, please check out that slide. It was awesome. We have the potential energy equation. Potential energy equals mass times gravity times height. And in case you forgot, here's the little list of variables, what they mean, with their units, and all that good stuff. One thing I just want to remind you of, a lot of people did this really well, but gravity is positive 10 for this. The reason why it's positive is because energy doesn't have a direction. You can't have 5 joules right. It doesn't make any sense. Energy is a scalar quantity. There's no direction. So we're not going to use the negative for gravity. The kinetic energy equation is 1/2 times the mass times the velocity squared. So here are our two equations, and here are our variables. As you work on some of the problems, you may want to turn back to the slide and pause it, or just simply take notes of this, so that when you do the problems, you can see all this very clearly. Okay, this is important. So far, it seems kind of basic. We're just plugging into equations. It's not so bad. But anytime I'm going to add a concept into it, it gets a little bit tricky. So here is the concept that I'm going to add into it. I want you to understand that height connects to potential energy. These two things are connected. If you have more height, you have more potential energy. That makes sense. If you lift something higher in the air, the more it can fall. That's kind of obvious. If you have less height, you have less potential energy. You can even say that height and potential energy are directly proportional. Here's something I want to remind you of though. If something is on the ground, if something is just lying on the ground, what's its height? Its height above the ground, the height is 0, and that means the PE is 0. This is important. I need you to understand this. If something is sitting on the ground, it has no potential to fall. It's already on the ground. It can't fall anymore. So it no longer has the potential to fall. It no longer has potential energy. Whereas velocity connects to potential energy. So I want you to understand this. Height connects to potential energy. Excuse me, I think I misspoke. Velocity connects to kinetic energy. So the height determines the potential energy. The velocity determines the kinetic energy. And this is really, really important. When we're talking height, we need to be thinking potential energy. When we're talking velocity, we need to be speaking about kinetic energy. These two are interchangeable. They are absolutely connected. So I need you to make sure that you understand that anytime we're talking about changing velocity, we're talking about kinetic energy. Anytime we talk about changing height, we're talking about potential energy. Now, one more thing I want to let you know. So for potential energy, nice. That was a straight line, except for the end, but the first part, man, I'm on it today. When I talk about velocity, if something is at rest or still or not moving, if something is at rest or still or not moving, the velocity is 0 meters per second. And if the velocity is 0, the kinetic energy is 0. So I know some of you are looking at this like, okay, this is just really easy. This is a very, very important piece of information. This is something that people are going to overlook, and I really need you to make sure that you understand this, that potential energy connects to height, and when you have no height, you have no potential energy. Kinetic energy connects to velocity, so when you have no velocity, you have no kinetic energy. Okay, now, it says, what is the height? What is the height? So here we go. This is going to be a new question. We've never done a question like this before. So this is why I spent all that time kind of talking about how height and velocity connect to certain quantities. All right, so it says, what is the height? Well, I don't know, but I do know a strategy here. I'm going to write down my quantities on the side. I'm going to write h equals question mark. What is the height of a 50, nice, 50 kilogram. Kg is mass. We just have to know that, and if you don't remember that, look back at the other slide. Steel beam that has 7,000 joules of energy. Okay, hold on. Wait a minute, Bizzuto. That just says energy. What type of energy is it? Well, let's find out. While hanging at rest. Okay, this is important. So I know if something is at rest, the velocity is 0. And I know if the velocity is 0, what type of energy is 0? I know that the KE is 0. So if the KE is 0, what type of energy must the 7,000 be talking about? Potential. That has to be potential energy. Okay, I want to go over that one more time. We have two types of energy, potential or kinetic. So if we know it's not one, it's got to be the other. I also said that height and potential energy are connected. So that was another clue. So I had several clues in this problem to help figure out what type of energy is connected. So here's where it gets tricky. You have to understand what type of energies connect to what quantities to pick the right equation. So it says, what is the height? So we're looking for the height, PE, M. Okay, so we're going to use the PE equals mgh equation. Nice. Potential energy is 7,000 equals the mass is 50, the gravity is 10, and the height is question mark. Okay, let's do some math. 50 times 10. All right, so bring down the 7,000 again. 7,000 equals 500h. Oh, I got this. I'm going to divide both sides by 500. So I get a height of 14 meters. See that? Plug and chug. Once you know the right equation, it's not too bad. Okay, let's do another example. This one says, what is the mass? So we're looking for a mass, so M equals question mark. Okay, of a bird that is perched at rest. Okay, at rest means velocity is 0. That means the KE is 0. That means this problem must be asking about potential energy. On a branch that is 4 meters high, okay, so we're talking about height, okay, another clue that we're talking about potential energy that has 80 joules of energy. And now, because of those clues in the problem, we now know that those 80 joules reference potential energy. Nice. Okay, plug and chug. PE equals mgh. 80 equals m. Gravity is 10. And the height is 4. 80 equals m times 40. You divide both sides by 40. You get a mass of 2 kilograms. That's it. That's it. Nice. Okay. Now we're switching it up a little bit. I think you kind of saw this coming. Now it says, what is the velocity? And I know that velocity connects to kinetic energy. So I suspect that this problem we're going to have to use kinetic energy. 4 kilogram bowling ball. Okay. 4 kilogram bowling ball. 4 kilograms is the mass rolling on the ground. Here is another here is another hint. I was going to say height, but it's jumping the gun there. If you are on the ground, your height is 0. And if your height is 0, that means your PE is 0. So if your PE is 0, the energy we must be talking about is kinetic, because those are our only types of energy. So 18 joules of energy, okay? So if 18 joules of energy is indeed what we are working with today, we know that those joules must be kinetic energy, because we already know the potential energy. It's 0 because it's on the ground. So now we're going to plug this into the KE equation and solve. See, not so bad. Not so bad at all. Awesome. KE, so 18 equals 1/2 4 V squared. All right. How do we solve this? Well, we have to get the V by itself. So let's do half of 4. So 18 half of 4 is 2 V squared. All right. When I have a variable with a coefficient and an exponent, we have to divide by the coefficient first. So we divide both sides by 2. Okay, so I have 9 equals v squared. Okay, got to square root that jump. 3 meters per second equals the velocity. Nice, nice. Okay, whoa, I just saw a crazy number here, but it's okay. Now, it says, what is the mass? When it asks for mass, that doesn't necessarily tell me what type of energy we're using, because mass is in both types of energy. So I need to keep reading and figure out through another way. Okay, that is driving on the ground. Okay, on the ground. There you go. That's the hint. When you're on the ground, your height is 0. So if your height is 0, your PE is 0. That means the energy that we're dealing with is kinetic. Here's another hint. Here's a velocity. Because it says 15 meters per second, we know that's a velocity. And we know that velocity connects to kinetic energy. So the kinetic energy is in fact that crazy number of 281,250. Zito, why are you doing this to us? Relax, you can do it. It's not that bad. Let me show you. So this is what we're going to do. KE equals 1/2 mv squared. So I'm going to plug it in. 281,250 equals 1/2. We're looking for the mass, so we'll do 15 squared. All right. So Pizzuto, I just don't know what to do. Yes, you do. PEMDAS. Let's square that 15. I know 15 times 15 is 225. Bring everything down. Okay, that's it. You got it. Half. I can now take half. I can jump the half across the m and take half of 225. What is half of 225? 112.5 m equals 281,250. Now all I do is just divide. Don't be scared by the large numbers. Okay, gone. And then when I divide that, I should get something like, I believe, yes, the mass is indeed 2,500. Mass equals 2,500 kilograms. It's math, but it's not too bad. Nothing we haven't done before. You got this. The last thing I want to talk about is really, really simple. So I've been talking about energy. We have two types of energy, potential and kinetic. Is it possible to have both potential and kinetic at the same time? Yes. So your total energy is just the sum of all the energies that you have. So to get your total energy, you're just going to add your potential and kinetic energies. That's it. It's really easy. You know how to get potential, you know how to get kinetic, just add them, and that's your total. Simple. Let's see it. Don't forget, all energy is measured in joules. Energy is energy. So essentially, we talked about the two different types of energy. To get the total, you're going to add them up. So it says, what is the total energy of a 3 kilogram bird that is flying 4 meters per second while 7 meters high? Okay, this looks like a lot, but after everything we've done today, it's actually not going to be so bad. This is what we're going to do. PE equals mgh. KE equals 1/2 mv squared. We're going to solve for the potential, we're going to solve for the kinetic, and we're just going to add them. Okay, so PE equals the mass is 3, gravity is 10, the height is 7. That's it. That's it. Okay, I just multiply these together. My potential energy is 210 joules. Simple. For kinetic energy, oh, by the way, a lot of people, whenever I go over this, they're like, but wait, Pizzuto, we didn't use the 4 yet. Well, the reason we didn't use the 4 in the potential energy equation is because the 4 is the velocity. Some people will go ahead and put the 4 in for the g just because they see the number there, they want to plug it in. You have to remember how everything connects. Velocity doesn't connect to potential energy. So we didn't use the 4 in the potential energy equation. We're not going to use the 7 in the kinetic energy equation either, because height doesn't connect to kinetic energy. The mass is still 3, so the 3 is going to be used in both times. 4 squared. All right, that's it. So you just type that in your calculator. I believe that's 24. I did that in my head, but because it's important, I don't want to confuse anyone. I'll actually type it in. Ah, curses. No, I am right. Yes, I am right. I typed it in wrong. Typing in the calculator got me the wrong answer. Awesome. There it is. Potential energy, kinetic energy. So to get the total energy, you just add them up. Total energy is this plus this. So it's going to be 234 joules. That's it. Not too bad. One more real quick. What is the total energy of an 8-kilogram box at rest sitting on a 2-meter high shelf? Okay, we'll set it up. PE equals mgh. KE equals 1/2 mv squared. Awesome. So the potential energy, all right, PE equals the mass is 8, gravity is 10, the height is 2. The PE is 160. Love it. Love it. KE is 1/2. The mass is 8. The velocity. Oh. At rest means the velocity is 0. If the velocity is 0, that means the KE is 0. So to get the total energy, it's just going to be 160 plus 0. Sometimes the total energy can just equal one of the others. For example, if you don't have any kinetic energy, in this case, your total energy is going to be the same as the potential energy, because the potential energy is all the energy that you have. Simple. Don't forget to read the problems. That's it. Your homework tonight is going to be 10 questions working on this. It's really important that I see you work on this. Some people, I would say probably about 1/4 of the people, really like the Google Forms. We're going to go back to those eventually. I need to see the work on this because seeing the work, I can really help figure out where you guys are messing up. I know in the homework assignment that was last week, a lot of us really messed up questions 5 and 10, and I gave that feedback to people and they could fix it up. I want to see your work here. We'll get to back to the Google Forms, but the Google Forms are not good for showing work because unless you all say you really want to type in your math into a long answer form on Google Forms, I'd rather you just send me the picture. So that's what we're going to do today. If you have any questions, please reach out to me. I think this is probably the hardest thing that we've done since we've been on quarantine, but I know you can do it, and I'm here to help. Be well, and I will see you guys next time.